In today's video, we are discuss about spatial analysis, specifically the techniques of buffering and clipping. So these are fundamental tools in GIS that help us better understand spatial relationships and refine our maps for detailed analysis. Whether you are mapping road safety zones or analyzing areas around rivers and lakes, buffering and clipping will allow you to create more precise and meaningful maps. So let's get started. So first we should need to discuss about the spatial analysis. So before we jump into the practical steps, let's briefly discuss what is spatial analysis is. So the spatial analysis in GIS involves examining the spatial relationships between different geographic features to uncover patterns, make decisions, or solve real world problems. Okay, so what is spatial data? Spatial data can be expressed in several formats, including vectors and raster. We already discussed in our previous video about vector and raster. If you are not familiar with vector and raster, so please visit to the QGIS playlist and watch the related video. So, spatial analysis in GIS involves examining the spatial relationship between the different geographic features to uncover pattern, make decisions, or solve real-world problems. Okay. So, what is vector? Vector graphically represent the real world through points, lines, and polygons. So, with the help of these points, one can create lines which further give rise to enclosed space in the form of polygons. These vector data type allow the graphical mapping of physical objects found on the Earth surface. The data is kept in shapefile, which extension is .shp. So on the other hand, raster gives data a pixel grid representation, wherein each pixel reflects specific information such as color, measurement unit, etc. So conventionally, raster denotes imagery. In simple words, it's an image. However, in the context of spatial analysis, it refers to aerial photographs or satellite images known as orthophotographs. So, apart from vector and raster, non spatial data is represented by attribute. It refers to add on information to spatial data. For example, images, maps, or additional information that adds value to the spatial data of the object under consideration. So now move to discuss about importance of spatial analysis. So informed decision making, efficient resource management, risk assessment, improved planning and development, enhanced visualization. Okay, now discuss each of the line. So, informed decision making. Spatial analysis provides insights into geographic patterns, helping planners and policymakers make data driven decisions for urban development, environmental conservation, and public health. Now, efficient resource management by understanding spatial relationships. Organizations can optimize the allocation of resources such as emergency response teams, public utilities, and transportation routes. Risk assessment. So, spatial analysis is crucial for identifying high risk areas such as flood prone zones or areas vulnerable to pollutions, enabling proactive measures to protect communities and the environment. Now, the second last is improved planning and development. It aids in designing infrastructure and facilities in suitable locations, minimizing negative impacts on surrounding areas and enhancing accessibility. Now, the last one is enhanced visualization. Spatial analysis translates complex data into visual maps, making it easier to interpret, communicate findings, and engage stakeholders in various fields like agriculture, logistics, and urban planning. So today we will be
So today we will be focusing on buffering, creating zones around a feature, and clipping, extracting specific areas from larger datasets. Both are essential tools in creating focused, precise map for analysis. So we start from buffering. Okay, so we should start from the beginning. It's I already done this. I will give you an overview. We should disable these layers, also this one. So this is the base map. Okay, so I already downloaded the Punjab district boundary of Pakistan. So this is the Punjab boundary. Okay, and this is the waterway canal. No, this is the waterway canals, and this one is the motorway. We need to change the color. Mhm. Yeah, now it's fine. So I clipped this motorway layer from this one. This is the whole layer. Focus on this and this area. This is the whole highway motorways layer. So I need just the layer in this area of Punjab district, within Punjab district. I don't need this one, this one, this one. So for this we use clipping. This is the clipped area. Okay, so same is the case with the watery canal. Look at this. My area of interest is the Punjab district, which is have green boundaries. I need watery canal inside the green boundary. So I already clipped this one is also, so disable this one. Now look at to these layers. This layer just inside the Punjab district boundary. So we should start from the beginning, and we discussed one by one. So I'm starting a new project of GIS. Wait, save project, new, yes, okay. Now first drag the base map into layers. So these are the base map, and now where is the plugins? Click the OSM, place search. So I will select the Haryana Administrative Division of India. So first we download the India administrative boundary. Search India. Hit the enter button. Wait for it. Click on zoom button. So this is the India district boundary. Click on add object in new layer. It's already okay. So we should focus on Haryana. Sorry. Okay, now click on Haryana. Click the hit enter button. Download the administrative boundary. Click on zoom. Add object in new layer. Okay, so it's done. Now we change the color of the India boundary. Where is the simple line? Color, stroke width, apply, OK. Select a different color for it, apply, click OK. Now I need a watery canal or a river layers. Water canal. Click canvas extent, run query, and now it's downloading data, and it will automatically shows in the layers pane. Okay, done. Cross. So it's a polygon. We don't need this watery canal. Okay. Apply. Okay. Look at these orange lines. These are the canal. Okay. So now let's start with buffering. So buffering allow us to create a zone or area around a feature. So for this, you should have a layer, and I already make a video on it from where to download the vector and raster layers. Okay. If you need simple layers, you can download free vector data from sites like Natural Earth, OpenStreetMaps, or USGS Earth Explorer. Okay, now select the layer you would like to buffer. So I need this layer to buffer. So for this, click on vector, click on geoprocessing tools. At the top, you will see buffer. Click on it. Okay, it will shows error here. So for this, we need to export this layer with the geographic coordinates. Sorry, geographic projection. So for this, first we need to check Gujarat granule. So it comes in 42N. So we should first we set the path for the export image layer. Click on it, set the path, waterway canal updated UTM zone 42N. Click on it, click here. Okay, 42N UTM zone 42N. 42N. Click OK. Leave the other option as it is. Click the OK button. Okay, now the layer is exported. Okay, now remove this one. Okay, now let's go to vector. Click on the geoprocessing tool, select the buffer tool. Now look at this, the error is removed. Now you will need to enter the buffer distance. So this distance will determine how far out from the feature the buffer zone will extend. For example, if you are analyzing a river, you might set a buffer of 500 meter. You also change the points as kilometer, feet, yard, miles. So for this time I selected a meter. How much distance? 500 meter. Okay, and it's equal to half kilometer zone around the river. So I left the this field as it is. It will create a temporary layer. Click on the run button. Now you will see a new layer, this one, appear on the map showing the buffer zone. Look at this. There is a huge difference. This is the buffered layer. This is the, sorry, this one. This one and this one. There is a huge difference. We need to change the color of this. For example, green color. Now and now see the difference. This is the main vector layer and this one is the buffered layer. Around the canal it will create a buffer zone which is a 500 meter. So you have successfully created a buffer. This can now be used for further analysis or to create zones that indicate areas of influence or concern around a specific feature. So now let's move on the clipping. So clipping is useful when you want to focus on a specific area within a large data set. For instance, if you have a map of a country, so there we have already selected country and you want to analyze a particular region. Clipping allows you to extract just that region from the entire dataset. Dataset mean the whole. We have the dataset is the country administrative boundary, which is India. So to begin, you will need two layers. We have already one of the area you want to clip, and the other one is defined the boundary. So in this example, we will use a land cover map as our main dataset and clip it to the boundary of a specific city. So first we need to zoom out. Where is the water canal? No, this one is the, okay. Look at this blue layer. This is the Haryana district of India, Haryana state of India. Now look at this. The green one is the canal areas, watery canal areas, which is inside the Haryana district and outside the Haryana district. So we just need the Haryana district watery canal, which is inside the blue border. So for this, we used to extract this area using clip tool. So go to the vector layer, click on the geoprocessing tool, select the second option, clip. Okay, input layer is which one? Which is Haryana district. OSM 1942601, this one. And the overlay layer is the buffered layer, which is the green one, this one. So you can also set the path of the clipped data, but for me it's okay. We'll click the run. Now look at this. The river, the canal areas is clipped, which is just inside the Haryana district boundary. And that's it. You now have a refined data set limited to your specific area of interest. Clipping is great for narrowing down large data sets, so you are only working with the data you actually need. So, to wrap up, let's quickly go over a few practical applications of these tools. So, buffering is commonly used in environmental studies, urban planning, and disaster management. For example, you could buffer area around rivers to analyze flood risk zones or create safety zones around hazardous areas. And clipping is especially useful when working with the large data sets. If you are studying land use in a specific city, clipping allows you to extract just that city from a national dataset, making your analysis much more manageable and focused. So, thanks for watching. Today we covered the basic of buffering and clipping in the QGIS. And if you have any questions, feel free to drop them in the comment below. See you in the next video.